KURINJI Senior Secondary School, CBSE, Namakkal.
Successful result producing school in state every year.
Administered by the Board of Directors with over 35 years of experience in the teaching field.
Special attention on art, craft, music, dance, silambam, yoga, skating and karate.
Focus on Hindi Sabha and Spell Bee Olympiad exams.
Smart class for effective and innovative learning and well-furnished library.
Solitary importance on sports and games in state and national level.
WhatsApp facilities to know activities of students and school inside the campus.
Free bus for LKG to 8th standard.
Free, hygienic and nutritious food.
NEET, JEE, IIT coaching experts from Rajasthan and Andhra Pradesh along with our effective teachers.
Admission registration for classes LKG to +2.
KURINJI Education Institution, Kavetipatti, Namakkal. Admission in progress. CBSE, KG to 12, contact 9025895176. Metric 6 to 12, contact 9344567484. For online admission, log on to www.kurinjischoolnkl.in.
In continuation to the last class, in this class we are going to discuss next 3 exercise problems. So problem number 13, 14 and 15. Okay, right. So if you observe carefully, in this class, that is what numericals 5, right? So already we discussed 12 example problems, 12 exercise problems, right? The example problems already we discussed when we were in a discussion about theory, that is what derivations and etc., right? So now our concentration is on exercise problems, right? So already 12 exercise problems completed. Now it is 13th one, right? After completion of that, we will go for 14th and then 15th and so on. Okay, right. See here. First, I will read the problem. You observe carefully and try to imagine what's happening in the problem. Right? See this. A small telescope, right? A small telescope has an objective lens of focal length 144 centimeters and an eyepiece of focal length 60 centimeters. Full stop. What is the magnifying power of telescope? What is the magnifying power of telescope? Okay, right. Then what is the separation between the objective and eyepiece? What is the separation between the objective and eyepiece, right? So when I am explaining this problem, you have to get into your mind what is telescope, right? So what are the types of lens present in that, and what about the focal length of those two things? That is, for example, what is the focal length of objective lens and what is the focal length of eye lens, right? At the same time, where is the object and what is the position of the image formed by objective lens, and then what is the image formed by the eye lens, right? So this is the total information you have to get into mind so that you can enjoy the solution what I am going to say. Okay, right. See here. First, we are going to write the given things. That is what f naught, focal length of the objective lens, that is 144 centimeters, and then fe, that is what 60 centimeters, right? That is what fe 60 centimeters, right? See here, it is what not 60, it is what 6.0. See here also there is a point, right? So you just keep in mind it is 6.0 centimeters. So means 6 centimeters. So it is also 6 centimeters, right? And now first we are going to find the magnifying power. The magnifying power of the telescope. Okay, right. So for the small telescope, that is what set in normal adjustment, right? So the formula for magnifying power is f naught by fe. Magnifying power m is equal to f naught by fe. So f naught is 144 centimeters. F naught is 144 centimeters, right? F naught is 144 centimeters, and then fe is 6 centimeters, right? Fe is 6 centimeters. So 144 by 6 is equal to 24. 144 by 6 is equal to 24. And you know that magnification has no unit because the numerator and denominator, the quantities available in numerator and denominator having the same units, no, that is what centimeter and centimeter. So that magnifying power has no units, that is what 24. Now separation between the objective and eyepiece, separation between the objective and eyepiece, L is equal to, capital L is equal to F0 plus Fe, right? Okay, here directly he is writing just the separation between the objective and eyepiece, F0 plus Fe, right? So F0 is 144 and Fe is 6, it will be 150 centimeters, 150 centimeters, okay? So my sincere request here is, when I am explaining the problem, here in our physics, imagination is important. So you have to visualize the problem, you have to imagine the problem, what's going to happen. What's happening in the problem, you have to completely imagine, you have to completely visualize, right? Then you can enjoy the solution along with the problem, okay? See here, F0 is equal to 144 centimeters and Fe is equal to 6 centimeters, and this is what magnifying power, and then separation between the objective and that is what eyepiece, that is what eye lens also you can call it as F0 plus Fe is equal to 150 centimeters, okay, right? Next problem, 14th one, right? Next problem is 14th, right? First I will read the problem. See here, a giant reflecting telescope, at an observatory has an objective lens of focal length 15 meters, full stop. If an eyepiece of focal length 1.0 centimeters, means 1 centimeter, is used, what is angular magnification of the telescope, right? So by giving some of the quantities, he is asking what is the angular magnification, right? So what are the sum of the quantities, what are the sum of the quantities, that is what they have given. See here, it is what objective lens focal length, that is what F0 is 15 meters. Similarly, eyepiece of focal length, that is what Fe 1 centimeters, okay, right? Next, so problem not completed, still there is a second, that is what, see here. So this is the first thing we have to find, and now the second thing, that is what, if this telescope is used to view the moon, what is the diameter of the image of the moon? What is the diameter of the image of the moon formed by the objective lens? Okay, and they have given some information, that is what the diameter of the moon is 3.48 into 10 to the power of 6 meters, and the radius of the lunar orbit is 3.8 into 10 to the power of 8 meters, right? So this is the information they have given, right? Now we are going for solution. See here, observe carefully, So as I told, in every problem, first you have to understand the problem. Understanding means visualization, imagination, right? Imagination and then complete visualization. After completion of that, you have to identify the quantities what they have given. At next, you have to identify the quantity what we wish to find, right? So then we have to write the things what they have given and what we have to find. Afterwards, identifying the formula. So identifying the formula is nothing but the relation among given quantities and the quantities what we should find. That is nothing but formula. Next, substituting, right? Substituting the given quantities, right, numerically. So units also important while substituting. After completion of the substituting, calculating, right? So along with unit, in our physics, calculating, that is what getting the result, along with unit also important, okay? Suppose if unit is not correct, means the entire problem will be, that is what you didn't solve the problem properly. That is the main thing, okay, right? See here, so in our problem, that is what we discussed. Here first we are writing the given things, that is what F0 is equal to 15 meters, right? And then Fe is equal to 1 centimeter. Fe is equal to 1 centimeter, that you can write it as 0.01 meter, no? Right. Now first here he is asking to find angular magnification of the telescope, okay? angular magnification of the telescope. So what is the angular magnification of the telescope here? It is what? 1500. See, because the formula is F naught by Fe, no? F naught by Fe is equal to 15 by 0.01, that is equal to 1500. That is the angular magnification. Angular magnification. Okay, ma? Right. Next thing. See here. Let D be the diameter of the image in meters. We can write. See here, I am requesting you to please understand. Here we are comparing the object with the image. We are comparing the object with the image. See here, the object is moon, ma. Image is, that is what? Image of the object. That is what? Moon's image. Moon's image, right? So according to geometrical mathematics, if you compare that, okay, in this situation we can write, that is what? Small d by f naught is equal to, small d by f naught is equal. What is the small d? Which is the diameter of the image. Small d is the diameter of the image in meters, because unit also important, no? Because all the quantities what we are taking in one system of unit while substituting in the formula, right? See here. So it is what? T by f naught is equal to diameter of the moon divided by radius of the lunar orbit. Diameter of the moon divided by radius of lunar orbit, right? So we are substituting, that is what? 15 meters is f naught, and diameter of the moon according to the given problem, it is 3.48 into 10 to the power of 6 divided by radius of lunar orbit is 3.8 into 10 to the power of 8. Okay, right. So do this process mathematically, and that is what? If you take this 15 to that side, 3.48 into 10 to the power of 6 into 15 divided by 3.8 into 10 to the power of 8, right? So which is what? Which is what here? Small d is equal to 13.73. 13.73 centimeters. 13.73 centimeters will be the final answer. That is what? Diameter of the image of the moon. That only he is asking to find, right? So at last he is asking to, at last means in second part of the problem, he is asking to find what is the diameter of the image of the moon formed by the objective lens. So that is 13.73 centimeters. Okay, right. Now we are going to see next problem. That is what? Problem number 15. Okay, see here. First I will read the problem, then we will go for solution. See here. Use the mirror equation to deduce. Use the mirror equation to deduce that. See here. When I told this, that is what? Use the mirror equation. Immediately every student has to get into your mind, what is mirror equation? You know very well, 1 by f is equal to 1 by u plus 1 by v. That is what? Mirror equation. That is what? Mirror equation. Okay. So use the mirror equation to deduce, right? Use the mirror equation to deduce that. First thing, A, B, two things. Here we have to find, we have to do 4 things more. A, B, C, D. Okay. So the first thing is what? Use the mirror equation. Use the mirror equation to deduce that, right? First A, that is what? An object placed between small f and two small f's of a concave mirror produces a real image beyond 2f. Okay, that is what I am saying. See here, A, an object placed between f and 2f of a concave mirror produces a real image beyond 2f. This we have to prove. This we have to deduce. Okay. Next thing is here. Next B, that is what? A convex mirror always produces a virtual image independent of the location of the object. That is the second we have to prove or we have to show. Third one is, that is what? C, the virtual image produced by a convex mirror is always diminished in size and is located between the focus and the pole. Between the focus and the pole, right? Next, that is what last D. It is what an object placed between the pole and focus. An object placed between the pole and focus of a concave mirror produces a virtual and enlarged image, right? So this is the important problem. Here we are studying, that is what mirrors, okay? We are studying mirrors and we are proving, that is also important, okay? So use the mirror equation to deduce that A, an object placed between f and 2f of a concave mirror produces a real image beyond 2f. So when I am explaining this A, when I am reading this A, you have to get into your mind what is concave mirror, where is the f, where is the 2f, right? And what is meant by real image and where is 2f, right? So these are all you have to keep in mind, right? So what are the two sides of the mirror, right? So the front side and back side, right? So and mirror gives the reflection, right? So how a virtual image is going to formed in case of mirror, these are all you have to get into your mind, okay? Next, see here, B, a convex mirror always produces a virtual image independent of the location of the object, right? That is the second thing. And third one is the virtual image produced by a convex mirror. The virtual image produced by a convex mirror is always diminished in size and is located between the focus and the pole. Between the focus and the pole, okay? Right. Next, D. That is what an object placed between the pole and focus of a concave mirror produces a virtual and enlarged image. So why I am reading second time means I am thinking that you will get an imagination. So what is convex mirror, right? So what is meant by virtual image? What is meant by diminished in size? What is meant by magnified in size? That is what enlarged image, okay? That and all I am expecting you to imagine, okay? Right. Now we are going to see the solution, right? So this is what mirror formula. So actually mirror formula is 1 by f is equal to 1 by u plus 1 by v. So the same thing you can also write like this, no? Right. Now for a concave mirror, f is less than 0 and for an object on the left, please try to imagine. Now for a concave mirror, f is less than 0, right? F is less than 0 and for an object on the left, u is less than 0. U is less than 0. See here. These are all what A. So first we are going to discuss about A. That is what an object placed between small f and 2 small f of a concave mirror produces a real image beyond 2f. So where he kept the object? Between f and 2f. Concave mirror, he placed the object between f and 2f, right? So when he kept between f and 2f, you know, that is what left side means it is what negative x-axis now. Right side means it is positive x-axis now. And here the mirror is present. Mirror is present here. It is what negative x-axis. It is what positive x-axis, right? So based on that he is saying, so when f is less than 0 and for an object on the left, u is less than 0, right? Because both are present on the left side and it is negative x-axis. When the values are available in minus, so automatically less than 0, right? Next, see here, you can write it as 2f is less than u is less than f. First f is present here, right? Then 2f is here, in between these two u according to the problem, okay? So when this is correct, you can write this one mathematically, right? So this is the condition I am writing based on the physics concept. Afterwards, this is mathematically. Please try to understand. I am writing mathematically. Next, from this one is also mathematically, right? Okay. After this, just I am going to, that is what, add 1 by f for all these things. This is what 1, 2, 3. Then I am getting this one. Okay, right. Next, or 1 by 2f, right? So if we do this process, 1 by 2f is less than or equal to 1 by v, is less than, because 1 by f minus 1 by u is equal to 1 by v, no, that is, and this is what, 0, no, right. So this is 1 by 2f is less than 1 by v is less than 0, right. So here you can say that v is less than 0, no, from this. When v is less than 0, what does it mean? The image is formed on the left, no. If v is greater than 0, image formed on the right. Okay. So when the image is formed on the left, that only he is asking, no. So what he is asking? Produces a real image beyond 2f. See, but based on this, you can also say 2f is greater than v. 2f is greater than v, right. So based on these two things, that is what, v is less than 0 and 2f is greater than v, you can say that. And here to conclude, you also keep in mind the ray diagrams in case of concave mirror. Okay, right. So here when it is 2f is greater than v and v is less than 0, you can say that when object is placed between small f and 2 small f of a concave mirror, it produces a real image beyond 2f. Okay, right. See here some other information they have given, that is what 2f is same thing, he is repeating modulus, right. 2f and v are negative, that is the real image is found beyond 2f. Next, b. For a concave mirror, this you already know, ma. For a convex mirror, this you already know, f is greater than 0, and for an object on the left, u is less than 0. U is less than 0. F is greater than 0 for an object on left, and u is less than 0, and this is what mirror formula, you know, right. Here as f is positive and u is negative, so that 1 by v is greater than 0, no. When 1 by v is greater than 0, you can say that v is greater than 0, no, right. That is what. Next, this shows that whatever be the value of u, a convex mirror forms a virtual image on the right. So based on this data, you can conclude that whatever be the value of u, a convex mirror forms a virtual image on the right. That only he is asking, no, right. So virtual image is independent of the location of the object. Next, see this. Now we are going to see the C. So in that C, what he is asking? The virtual image produced by a convex mirror is always diminished in size and is located between focus and pole. Right? So that we want to prove. See here. For a convex mirror, f is greater than 0, the same data we are using here. F is greater than 0, and for an object on the left, u is less than 0. So mirror formula, that is what 1 by v is equal to 1 by f minus 1 by u. 1 by v is equal to 1 by f minus 1 by u implies that 1 by v is greater than 1 by f, no. Think mathematically, right? So when this is correct, this will be correct. 1 by v is greater than 1 by f. Here minus 1 by u is a positive quantity. When it is correct, you can say this one, no. So the same thing you can also write like this, no. V is less than f. When v is less than f, what can we say? The image is located between the pole and focus of the mirror. And we can also say that the virtual image produced by a convex mirror is always diminished in size and is located between the focus and the pole and the focus of the mirror. Okay, so this is about C. Next, D. See here, the last thing we have to deduce. An object placed between the pole and focus of a concave mirror produces a virtual and enlarged image, right? An object placed between the pole and focus of a concave mirror produces a virtual and enlarged image. Okay, right. So it is the mirror formula, you know, ma. So for a concave mirror, you know that f is less than 0 and for an object placed or located, for an object located between the pole and focus, for an object located between the pole and focus of a concave mirror, f is less than u less than 0. F is less than u less than 0 when it is correct. When it is correct, you can say that 1 by f is greater than 1 by u, or 1 by f minus 1 by u is greater than 0, or 1 by v, because 1 by f minus 1 by u means you can write 1 by v, no? So 1 by v is greater than 0, right? So when 1 by v is greater than 0, you can say that virtual image is formed on the right. Virtual image is formed on the right. And you can also write, that is what 1 by v is less than 1 by u. That is what we are taking only magnitude. That is what modulus, right? So 1 by v is less than 1 by modulus of u, or v is greater than modulus of u. V is greater than modulus of u. Therefore, m is equal to, m means what? Magnification. It is v by u is greater than 1. V by modulus of u. Modulus of u means we are omitting sign, just we are taking only the magnitude. We are taking only the magnitude, right? So that is greater than 1 now, right? So when it is greater than 1, what does it mean? Image is enlarged. Image is enlarged, right? The size of the image is greater than the size of the object. Size of the image is greater than the size of the object. Okay, right. So what I am saying is, here in this class we focused on 3 exercise problems, right? So 13, 14 and 15. 15th problem is very important. Romba mukyamana problem. Because in 15th problem we are discussing the entire ray diagrams of concave mirror and convex mirror, and we are checking point to point, and we are also checking about the possibilities, and we are also giving the proof, right? So that's why 15th problem is very important for us to understand reflection and mirrors, especially spherical mirrors. That is what concave mirror and convex mirror. Okay. So before this problem we also focused on 2 more problems, 13 and 14. In 13th problem we discussed about a telescope, right? And 14th problem also we discussed about telescope. There itself we discussed about the magnifying power. Okay. And in 14th problem we find out the diameter of the image of the moon. Okay. So the 15th problem you watch again and again, right? You just try to get the clarity. Okay. Right. So in next problem we will discuss next continuation problems 16, 17, 18 and so on. Okay, ma? Thank you.